So today we're going to talk about algebra tiles, which is basically this tool that we can use in math to help understand what operations we're doing with polynomials. Now, usually algebra tiles are something that you use physically, and in class we're going to physically use them, but sometimes it can help to draw them out as well, and I want to show you how they basically work. So we have three different shapes we're going to be working with. We have little red ones. They're red so we can tell the difference between the other ones. There's long, skinny green ones. And then there's a big square that's green as well. I'm going to scribble color them like this, but you get the idea. They're pretty green, like filled in all the way. All right, this one represents 1. Let's make that actually look like a 1. This is 1 without any variables or anything like that. So if we were measuring something, let's say we measured something and it's like 3 shoes long, those are my shoes, that's 3x, plus the little bit at the end, like the 4 centimeters, we would make that 4 centimeters by using four of those little red tiles, okay? They are constants. This green one, we don't know how long it is on this side, so we call it x to represent that it's x long. So in this case, it might represent 1 shoe length or whatever we're talking about. This box, hopefully you figured it out by now, it's x long on both sides. So what we do when we do x times x, length times width to find area, it's x squared. And remember, x is not the same as x squared. You can't add them together. So that's why they're different sizes. So the way that algebra tiles work is that we can represent stuff using these tiles. So let's do the first one we said. This one's 3x plus 4. So we have those 4 little 1 tiles. And then to get the 3x, we would need 3 of the long skinny green tiles. That would be 3x plus 4. If we did something like this, 2x squared minus 4x minus 2. So I need 2 of those big green ones. Then I need 4 of the skinny ones. And then I need 2 of the red ones. So now we have to be careful because when we're dealing with negatives, we have to actually show how they're negative. So what we do is we leave them blank. So on the physical tiles, they're green on one side, and on the back side, they're white. They're blank. So those to me are the negatives. A lot of people do it different ways, as long as you can tell the difference between positives and negatives. Sometimes it's easier to write the actual negative on the tiles. It's up to you. All right, so the reason we do algebra tiles is so we can do multiplication and division more easily. I'm going to show you 2 examples of multiplication and then 2 examples of division. So let's do something pretty basic to start. 2 times 2x plus 1. Okay? The way this works is we set up our tiles on this grid. What we're going to do is we put whatever the coefficient is here in this space right here, and we put whatever is being multiplied in the brackets up at the top. So I have 2, which means I'm going to draw 2 little squares. Okay. And then I have, and that came from there. And then the 2x plus 1, I'm going to draw my 2 long green squared rectangles. 2. And then 1 little green red one at the end for that plus 1. All right? Now, to find the answer, we need to multiply and fill in this space here. And what you're going to notice is it's always going to make a perfect rectangle based on the size of the tiles you've put. So what you have to do is you have to put in the tiles that fit. Now, if I tried to put in an x squared, let's draw it the right size, like that, this wouldn't actually be right because you can see the cracks don't line up. The cracks lined up on this side, that's okay, but this crack is wrong. So, if I tried to put a little red one, these cracks line up, that's okay, but then these cracks didn't line up. So what you're going to notice is that you're actually supposed to put a long green skinny tile that way. If I put one this way, you would notice, again, the cracks don't line up. So I'll put one right here, and I'll put another one here, 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 and we'll color them all in. Okay, and then you'll notice at the end, there's only space for a little square, so we're going to put one right there and one right there. The idea is what we're doing is we're saying, and let me erase these highlights. Okay, we're taking this term, the 1, and multiplying it by what is here. So 1 times x gives me an x. Now I'll do the next one. 1 times this x gives me another x to put in there. Then I do 1 times 1 gives me 1. And that's it. Then we repeat it for the bottom row and do it again and again and again. Okay? What we'll find is whatever is in this box in here is our answer. So I count 1, 2, 3, 4 x's and 1, 2 singles by themselves. That's the answer. Okay? I want you to realize that you can still do the distributive property with the rainbows, the thing I showed you before. This is just a way to visualize it. It's important to know both because we want to understand like what this can represent in a situation. And what this can represent is a rectangle that we're making, like the area of that rectangle we made, using the length and the width. Let's do one more quickly. A little bit trickier this time. Okay. So I wrote 2x times 3x minus 2. So my 2x goes on the side. My 3x minus 2 goes on the top up here. And remember, because it's minus 2, I have to make them like that to show that they're negative. So I'm going to fill it in. When we do x times x here, it's going to give me a big ol' x squared. And again, another one here, and another one here. Okay. Then when I do x times 1, I get x. And remember, it's positive x times negative 1 gives me a negative x. Same with here. And what you're going to notice is this will be the exact same because we're again multiplying by x just like we did before. What you'll notice is that whenever you do these questions, you'll always get that perfect rectangle and everything will look like it fit together properly. So my final answer I can write 6x squared, we got 6 of those, minus 4x, because we had 4 of them, but it's negative because of the multiplication that happened. That's it. Division works very similar. We're actually going to do the exact same examples backwards in another video.